You jog 1 kilometer north, 3 kilometers 60 degrees east of north, and 3 kilometers 20 degrees south of east. How far are you from where you started? Okay, picture. Let's draw a picture. So 1 kilometer north, 3 kilometers east of north, so it's over here, and south of east. So I'm still gonna be in quadrant one. So I'll just draw the coordinate system like this, just to make sure I'm not gonna be over here or off the page. So this is my x, y, east, north, west, south, okay, negative y. And we start drawing vectors. So we have 1 kilometer north, here it is, call that v1 vector. Then we have 3 kilometers at 60 degrees east of north. Well, this is north. North is this way. East of north is this way. How far? 60 degrees. So there, 3 kilometers. So 3 times that, there it is. Call this v2 vector. And this angle here is 60 degrees. Then we have 3 kilometers at 20 degrees south of east. Which way is east? East is this way. South of east is this way, down, and it's 20 degrees. And how many kilometers? 3 kilometers. So another one like that. And this is 20 degrees. Call that v3 vector. And that's it. How far from where you started? So we're asking how far is this point from here? So we're actually really asking for this vector right there. V final vector. If I can get the length of that V final vector, I'll have the answer to this question. So what's my equation here? Well, this is the long way around, but this is all the same point here. This point is equal to v1 vector plus v2 vector plus v3 vector. And that is equal to v final vector. So that's what I want to solve for. I want to solve for v final vector. So I have to add all these vectors up, and I can solve for this one. Now, these ones are in different coordinates, or they're going in multiple dimensions. So I have to break down these vectors first. Let's do that first. So this one's already aligned with my y-axis, so I don't have to break him down. V2 vector, though, I have to break him down. Got to break him down. 60 degrees. Here, 60 degrees. This one was 3 kilometers, and I'm looking for my y and x values. I want to break down into the x component and the y component of this vector that's going in two-dimensional space here. Okay, so x is equal to 3. X is going to be the sine, so it's going to be sine of 60. And y is going to be equal to 3 cosine of 60. Let's do the next one. So the next vector is my v3 vector. It's down at 20 degrees. That's a steep 20 degrees, but that's okay. This is 20 degrees. Here's another 3 kilometers, and I want to find x and y. So x in this case will be, it's going to be 3 times, this is the cosine of 20 degrees. And y is going to be equal to 3 sine of 20. Sine of 20, that's right, okay? So let's figure out those values here. So 3 sine 60 is 2.598. 3 cosine 60, 1.5. 3 cosine 20, 2.819. 3 sine 20, 1.026. Okay, I got all my components. Now we can write down this vector. Now we can do the math here. So v1 vector, v2 vector, v3 vector, add all those up. I'm going to get v final vector. Okay, so v1 vector, let's do, oh, it has 0 x components, and there's nothing in the x. So 0 x hat plus 1 y hat. v2 vector, well, I just did the components on that, right? So I know how much it went in the x direction. The v2 vector went this far in the x direction. I know that. It's right here, x. So it's 2.598 x hat. And in the y direction, it went positive. So it's positive here of plus 1.5 y hat. Here, oh, we went negative y. I have to remember that. Okay, so we went positive x. Here's positive x. So the x value was 2.819 x hat. And we went negative y. We went down in the negative y direction. So from here, we went across and then we went down. Those are the components. That's what we're trying to get here. So it's going to be minus 1.026 y hat. All right, let's add our components here because we can't add it. We can't. X and y do not play together. You can only add the x's and y's separately. So 2.598 plus 2.819 is equal to 5.417 x hat, and 1 plus 1.5 minus 1.026 is equal to 1.474 y hat. Okay, there's the vector. So it is 5.4 in the x direction. This distance here, 5.417 x direction. And in the y direction, it is 1.474. And that makes up my final one. I want to know the magnitude though. So the magnitude of this guy, the magnitude of this vector, will just be equal to the square root of the vx component, the vector in the y in the x component, so the v final x component squared plus v final y component squared, right? So this 5.4 plus the squared plus this one squared will equal this one squared, so I square root the whole thing. So it's going to be equal to 5.614 kilometers.